welcome to your deep dive. Today we're going deep into database design.
Oh, exciting.
Yeah, it's gonna be fun.
Yeah. It's amazing how often these concepts pop up, even if you're
Right.
not someone who's like a tech person.
Exactly.
Okay.
Okay, so I was looking over these notes that you sent,
Okay.
and it starts with this hotel database, which is interesting,
Yeah.
but then it takes a turn, and we end up in the world of Harry Potter.
Of course. What better way to
Yeah, exactly.
Johnny Rowling?
And databases. Who knew?
It's all connected.
So let's talk ERDs, which, from what I understand, are like the blueprints
Yes.
for databases.
Absolutely, yeah. Entity relationship diagrams, or ERDs
Yeah.
for short.
Okay.
They're a way to visualize how everything's structured and how it all kind of fits together.
So if these are like the blueprints, what are the key elements?
So you start with entities, which are like the main things you're tracking in your database.
Okay.
Think of it as the nouns, you know.
Okay, mouse. Okay.
So in the hotel example, your entities would be hotel and hotel manager.
Okay, so we got the players. Now what about their characteristics?
Right. So that's where attributes come in.
Okay.
Each entity has attributes, which are basically just characteristics or details about that entity. So for hotel, you'd have attributes like hotel ID, the name, the location,
Makes
number of rooms, all those things that describe the hotel.
Okay, so the entities like the who, and then the attributes are the what.
Exactly.
Got it. So how do we show in our blueprint how all these entities connect?
Right. So that's where relationships come into play. And there are different types of relationships,
Okay.
but essentially it shows how those entities are connected.
Okay.
So for example, a hotel has a hotel manager.
Oh.
So that's typically a one-to-one relationship.
Got it?
One hotel, one manager.
Okay.
One manager, one hotel.
Yeah, makes sense.
Right? And then
A book has one author.
exactly.
So this is where I think the Harry Potter example is interesting because we have that table
Yes.
where J.K. Rowling's information is
All there.
repeated over and over again.
And that's what we call data redundancy.
Okay.
And you might think, well, who cares?
Right.
But it can cause a whole bunch of problems.
Yeah, if you ever have to update it, you got to update it like 20 times.
Exactly.
Yeah.
You got it. So we need a better system. And that, my friend, is where database normalization comes in.
Okay, and that's what we're going to talk about next.
We'll get into that in a bit.
So data redundancy sounds like a real pain.
It can be, yeah.
Like having a bunch of sticky notes and then you got to change the info on all of them.
Yeah, it's a mess, but luckily there's a solution, and that's database normalization.
Okay, so that's the magic solution.
It's like organizing those sticky notes into a nice, neat system.
Okay, so using our Harry Potter example, how would we apply that to that table we were looking at?
Okay, so we want to break down that big table into smaller, more manageable ones.
Okay,
So instead of having all that J.K. Rowling information repeated for every book,
right.
we make a separate table just for authors. And in that table, we'll have things like author ID, author name, all the author-specific information.
Okay, so then the books table, that'll just have the book info.
Exactly. So we'll have book ID, title, publication date, all that good stuff.
Okay,
But here's the key, no pun intended.
okay.
We need a way to link them back together.
Right, because we still need to know who wrote which book.
Exactly. And that's where keys come in.
Okay, tell me more about keys.
So in our authors table, we give each author a unique author ID. This is called the primary key.
Okay,
It's like their special identifier.
got it.
Now, in the books table, we include a column for author ID as well, but this time it's called a foreign key.
Okay, so it's like a cross-reference.
Exactly. It creates that link between the two tables.
Okay, so if we look up a book and we want to know the author, we can just
You just follow the author ID.
follow the link?
Yep, back to the authors table, and boom, there's your author information.
Okay, so it's organized and efficient.
Exactly. Plus, it reduces errors because we only have to update the information in one place.
Right. No more changing J.K. Rowling's birthday like 20 times.
Exactly. Normalization to the rescue.
It's like, I don't know, organizing your spice rack or something.
Right. You wouldn't want duplicates of everything. It'd be chaos.
Exactly. So we've tackled data redundancy.
We sure have.
What else do these notes have in store for us?
Well, they dive into some examples from a university setting,
Okay.
which is perfect for illustrating different kinds of relationships.
Okay, so the first scenario talks about students enrolling in courses. I'm guessing this is where we go beyond one-to-one relationships.
Exactly. So when you think about students in courses, you're dealing with a many-to-many relationship.
Okay, right, because one student can take multiple courses, and a course obviously has multiple students.
Exactly.
How do we show that in our ERD?
Right. So in this case, we'd introduce what's called an intermediary table,
Okay.
sometimes called a junction table.
Okay.
And what this table does is it sits between the students table and the courses table.
Okay.
And it basically creates a link.
Got it.
So each row in that intermediary table would represent one student enrolled in one course.
Okay, so it's like a bridge.
Exactly. It bridges that many-to-many gap.
Got it.
And it helps us keep track of those enrollments without creating any redundant data.
So if we wanted to see all the courses a specific student's taking, we could use that intermediary table.
Exactly, you got it.
Okay, that makes sense.
And we can also use it to see all the students in a particular course.
Got it. Okay.
So it works both ways.
Okay, so the next scenario talks about courses being delivered by lecturers.
Okay.
Is that another many-to-many situation?
It is, yeah. Because a course can have multiple lectures.
Right.
And a lecturer can teach multiple courses.
Okay,
So again, we're dealing with that many-to-many relationship.
got it. Okay, next up, we've got lecturers and computers.
All right.
Now, is this where we get a one-to-many?
This is where we see a one-to-many,
Okay,
because one lecturer might have multiple computers,
okay,
but each computer is typically assigned to just one lecturer.
got it.
So that's a classic one-to-many relationship.
Okay.
And we would represent that differently on the ERD.
Okay, so the ERD, it's not just about, the entities and attributes.
Yeah.
It's about visually representing those different types of relationships.
It's about the relationships, yeah. That's key.
Okay, so then we get to the library database, which is kind of like the final boss
The big one, yeah.
of database examples.
Yeah, it brings it all together.
Because now we've got librarians and books and users and publishers.
It's a whole world of information.
So where do we even begin with something like that?
Well, we start by identifying our entities, right?
Okay.
So we've got librarian, book, user, and publisher.
Okay.
And then we start thinking about the relationships between them.
Okay, so like librarians and books, what would that be?
So a librarian can manage many books, right?
Right.
And a book might be handled by multiple librarians over time.
Right.
So again, we're in many-to-many land.
Okay, so another intermediary table.
Exactly. We'd have a table to keep track of which librarian is responsible for which book.
Got it.
And then if we look at, say, librarians and publishers,
Okay.
again, we see that many-to-many relationships, because a librarian might work with multiple publishers,
Right.
and a publisher works with many libraries.
It's all connected.
It is. It's like a big web of information.
It really is.
And that's what makes database design so fascinating.
It is. So we've covered a lot of ground today.
We have. From hotels to Harry Potter to libraries, we've seen how these principles can be applied in so many different contexts.
Yeah. And it's not just theoretical. It's really how information is organized in the real world. So next time you're on a website or using an app, think about the database design that's going on behind the scenes.
It's everywhere.
It really is. Well, it's been a pleasure as always.
Likewise. Always fun to dive deep into these topics.
Until next time.
See you then.